Hello, everyone. Welcome to another Friday Discovery session. My name is Kelsey Brasil. I'm a project manager here at Efficiency Canada. I'm also your go-to gal for the new DiscoverEE Career Hub that we've launched, which you can definitely hop into after the session. We're going to host a bit of a after party, if you will. So you can hop into the DiscoverEE Hub and reflect on what you've learned here today or ask any questions we might not get to. So I'd like to acknowledge that Efficiency Canada operates within Carleton University, and we acknowledge that the location of our campuses sits on the traditional unceded territories of the Algonquin Nation. But today I am calling you from Mi'kmaq. Before we get started, a reminder to everyone that our guest speaker will present for about 20 minutes, and then we'll open the floor to questions. Please use the Q&A box in the bottom of your Zoom screen, or you can wait till the end. You can raise your hand and I'll be sure to unmute you so you can ask away. We do have a hard stop at 12:45 Eastern so that everybody can kind of wrap up their lunch, breakfast, afternoon snack, depending on where you're calling from today. So to kick us off today, I'm pleased to welcome our guest, Shawna Henderson, a very famous Shawna Henderson, CEO of Blue House Energy. And today we're going to get a deep dive into deep energy retrofits, panelization, and total cost of building ownership. So please join me in giving Shawna a nice warm welcome.
Good afternoon, good morning. Hi, everybody. I am also joining you from Mi'kmaq. So deep energy retrofits, panelization, and total cost of building ownership. Okay, so this is me, and I have been doing this work since 1990. So I've spent pretty much all of my adult life soaking in information about building science and energy efficiency and focusing for the last several years on retrofit. So you don't have to read all of that, but I wanted to focus on 3 key studies that drove me in the direction that I've come in, and is a background to a bunch of stuff that's out there in research now. So 2001, I worked with Don Chugler at CMHC. We did a project called Energy Use Patterns in Off-Grid Houses. That led to me doing a study that was a paper study of modeling approaching net zero in existing houses. We did several house types in various climatic regions and cities across the country, and it's no surprise that a plain old bungalow in Vancouver came out as the best option for becoming a net zero house. And then in 2010, 2014, I worked with Anil Parekh, Enercan, on several different projects looking at focus groups with builders in 7 markets in various layers of small custom to large production builders. How can we get to net zero in steps? And what are the real and what are the perceived obstacles and barriers? So that led to current work that I'm doing, which is I have a client base for deep energy retrofits and net zero for new construction. I'm also working on this very cool project that is an extension of what I've done with Enercan in the past, benchmarking external retrofit potential in Atlantic Canada, looking at archetypes and the other things I have been involved in over the past few years here. So quick, what's a deep energy retrofit? Well, there are 4-ish retrofit streams. Typically, we're at the 20%. That is what EnerGuide for Houses rating system renovation upgrade report will push you to. Those recommendations are typically around 20%. We move to the left to the 30 to 50%. That's deep energy retrofit. If you use just the envelope, you're trying to drop the energy use at the envelope level. To get to a net zero deep energy retrofit, then you use the envelope and HVAC, so you're dropping your load so that your renewables are as small as possible. We always go with a whole building approach. So where possible, we always look at the building improvements first. In our case with this case study, we looked at the exterior envelope. And in the envelope, I always add ventilation. Ventilation doesn't exist for me in terms of mechanical systems. It's always, if I'm doing envelope improvements, the ventilation is always included in that package. So one of the other things about DERs is you really need to focus your measures and your goals. You need to prioritize goals, and you need to create laddered or phased pieces so that you can create a good timing with cash flow. So the work is being done, cash flow is being put out, and savings are being made so that nobody ends up with a worse cash flow at any given point. So this is what we're aiming at, is we have the initial utility bill, and we can work financing costs so the utility bill is lower and the financing costs are no worse than in terms of no worse, don't cost any more than an initial utility bill. But ideally what we want to get to is this particular one where there's actually gravy on top of that. And that happens over time because you have an initial capital outlay that is constant. That's your mortgage or your loan or your whatever financing you've got. And your savings are going to outstrip that initial capital outlay over time. So why? Because incremental retrofits don't do the job. We've been doing them for a long time. They're more difficult, they're more expensive when you're constantly reinventing the wheel as a sole practitioner or as somebody coming into the world of energy retrofits. You may not know enough about building science, so poor practices lead to unintended consequences, which lead to other problems for the occupant. But another bigger issue is that we lock in emissions for generations, which means that we've got tons of missed opportunities, and our time frame is unmanageable if we're going to just use these one-off pieces. So, for example, this is my favorite example because this is crazy. Between 1995 and 2018, there were 1 million energy retrofits put into NRCan's database. 4% of those put exterior insulation on a building. That's 40,000 over 23 years. There are 14 million houses in Canada, and I want you to think about how many houses every year need new siding. I'm guessing it's more than 1,800. This is a $14 billion a year industry in Canada, and there's over 3,500 firms doing siding. So we have missed over this last generation an opportunity to improve the envelope when the building needs recladding for the next generation. And the crazy thing is that it's not an expensive thing to do. We're looking at 15 to 20% of the total cost of a cladding job being focused on the thermal part of the envelope. On top of that, so we can reduce the energy use, but we also improve the air tightness by an average of 15%, which is pretty significant. No surprises here. Older houses are leakier than new ones. Retrofitting older houses is more effective than retrofitting newer ones. Not a surprise at all. But timing is everything because we have issues with maintenance and we have issues with component-led incentive programs. So for example, in this house, or this building, which is our case study, we had 2 pane sliders that were installed in 2018. And when we came to do the deep energy retrofit, because you can see that siding on this building actually is in really rough shape, it probably should have been addressed in 2018. But when we came to this particular project, the owner said, I'm not ripping out 28 3-year-old windows, no way. So this is one of the challenges. And windows are especially challenging. Here is my lawful neutral chaotic window characteristic breakdown. Always good to work in those places where we have removable cladding, where things are easily pulled in and out. But we'll go on from there. I'm speeding through this so y'all can answer lots of questions, or I can answer lots of questions. So incremental retrofits, they're not going to work for us. We will never make a dent in our emission reductions challenges unless we move into bulk aggregated retrofits. So how do we do that? Well, let's use panelized exterior insulation, which is a little bit of a step beyond putting rigid foam or mineral wool on the exterior of an existing house. It's inspired by EnergieSprong, which is out of the Netherlands. Essentially, they are putting a whole new skin over the building that includes windows, you can see here. It also includes a smart heating and ventilation and cooling system and a 40-year performance warranty. That program started in 2010 and that is in several different countries in the EU now. They have gone to serious automation on this. So we have all sorts of bonus points in terms of quality assurance, speed of production. They also have a few bonus points in terms of the fact that they have a lot of cookie cutter houses, which we don't have. And we can talk a little bit more about that in the question period. So panelized DERs, benefits, it's lowest total cost of ownership, which I'm going to talk about in the back end of the presentation, less expensive than component by replacement. The other big thing is that by doing an exterior retrofit, you can keep people in their houses. It's less disruptive to the occupants. So you have a whole much easier to manage construction schedule, and bonus points, bonus points, bonus points. It can be done now. We don't have to wait on the technology. So we have a Canadian pilot project that has wrapped up called the Pre-Engineer Exterior Retrofit Program that was run by Mark Carver. Looked at 3 primary research areas. How do we quickly and easily and accurately capture the building so we can measure it and put all that information into a more or less automated program to build them? What kind of panels are we going to look at? How do they get installed? And then let's look at the building science. We need to minimize the risks of failure. So where are we going to climb into or jump into a situation where we might have moisture problems behind a panel, or where we don't include, for example, ventilation. This project was focused on the building envelope, not the whole house. So here's our case study. So this was through a grant to Ecology Action Center here in Halifax. The project was called the Whole Housing Energy Retrofit Envelope, where Nova Scotia. Focus was on future-proofing social housing stock in Nova Scotia. So we looked at Part 9 low-rise MURBs. Here's the, as I said, Ecology Action Center is the project lead. Partners were Pembina Institute, Efficiency Nova Scotia, and their affordable housing program, and the Cape Breton Regional Municipality. So we did a chunk of diving into what drives this. Well, we have needs for deferred maintenance. There's also, emergency issues in terms of mechanical systems that need to be fixed or replaced. We have upgrades to meet codes or standards. We have known hazards in older buildings, and we have curb appeal. Some of these older buildings are looking pretty sorrowful. But the biggest thing that we found in our research was that insurance is probably the biggest driver for improvements to this older housing stock, because we found out that there are that in coming into play, better coverage or any coverage or better rates will require either a gut rehab of buildings that were built pre-1940 or updates that have been done within 25 years to plumbing, wiring, and roofing. And they're going to favor electric fueled houses over oil-based houses, buildings, sorry. This is specific to commercial insurance for MURBs, just to be clear. So that's a huge driver. We have a best candidate checklist. So the things that make it easy to choose, quicker-ish, easier, less complicated, prototype or first, it's basically triage. That's what this candidate checklist is. Are they ready for energy conservation measures? Are they ready for major capital upgrades? We want to have a simple building. We want to have something that doesn't have historical or heritage qualities, so we can do whatever we need to do to the building to improve it. Simple facades and facades that need updating. We looked at a heating reduction target that is from BC Step Code. Step 5, net zero for a new build requires a TEDI, a total energy density intensity of less than 25 kilowatt hours per meter squared. So we're in zone 6. So we just basically lifted that out of the energy step code as that's our target. Here's our building, built in the mid-1960s, 2-story MURB, 8 units, typical 2x4 construction, really not really well insulated. but the building itself, not super well insulated, has some nice brand new double pane sliders in it, the oil-fired boiler, and 8 individual electric DHW tanks live in the uninsulated basement that has an open window in it. So you can imagine how much energy is flying out the door there. So I'm going to probably be over a little bit on the 20 minutes, so I'm going to just keep roaring through this. Here's our replacement. The BAU is business as usual, basically replacing things over a 60-year period. Net zero retrofit on the right column there is those replacements, but also improvements. So this basically is looking at a long-term solution and how much it's going to cost over a 60-year period to do this work. We went with a low carbon standoff panel. So it's a 2x4 wood frame wall that stood off the existing house and is filled with the fibrous insulation. And of course, we had this challenge of figuring out what to do with our windows. So we did that too. Space and water heating system, we flipped to cascading water source heat pump that is built by these guys out of Newfoundland, ThermAtlantic. They have several systems already in place here in Nova Scotia and also in Newfoundland. Super cool system. So what about the dollars? Oh, the dollars. This is where it all jumps in, right? So the first thing we need to do with whatever, if it's a house or a building, it's an investment. You need to define what your investment period is. So here I've got 20 years. We actually went with 60 years in this particular model. And then you need to look at your alternatives. Why are you doing the work? Is it for resellability? Is it non-energy benefits? Is it cosmetic renovations? How are you spending your money and why do you want to spend it? Those are preliminary discussions. We typically see people going with, I need a payback of however many years. That's a very simple way of looking at spending money and getting it back. Sometimes we hear people talk about return on investment. I'm not going to go into these, but I'm just showing you the different ways that we find value. Internal rate of return is another one that folks use. Net present value is another one. Net present value actually is a good way to show over time how effective one or more projects are. So which one of any kind of scenario is going to be a better option for you over time. So we go to total cost of building ownership, which is the culmination of all of those things as far as I'm concerned. I really like it because you are comparing everything across the board, every single thing. It's all about data. Helps you make really good qualified decisions about where to spend money on a building. So it's a life cycle cost analysis, looks at operating, age-related renewal, maintenance costs, insurance, mortgages, tax, etc. Variables used in our investment analysis include this whole list over a 60-year time frame. So here's the number crunching on Brule Street. So the gray is the replacement cost, gold is the cost of the upgrade. You can see at the bottom here that we increased the capital cost by 92% for the net zero scenario versus the business as usual scenario. So business as usual replacement is the gray, net zero is the upgrade in orange or in gold. However, it saves us 70% in annual energy consumption, and it brings us below our energy use target. And what does that look like over time? Oh, not yet. So this is we're spending about $63,000 on an installed PV system, 21 kilowatts, sorry. So here's the rough calculation of options. If we look at business as usual, that's going to cost us $220,000. It's also going to be a continuing $1,600 a month expenditure for this owner. If he had to go through a gut rehab because that's how he could get insurance, that's $3,700 a month ongoing. If he took the net zero retrofit cost option, that's $420,000. What is it? 420? Yeah, that's right. Then we're looking at $1,800 a month on financing for 25 years. And after that, there aren't any more, there's no financing costs and there's no energy costs. Including PV and all of these upgrades, the value of the property actually goes up as well. Over time, the total cost of building ownership looks like this. The top red line as is. The green lines are two versions of net zero, one with an efficiency Nova Scotia subsidy. So total savings at year 25 are 4 to 12%. Total savings at 60 years are 40%, but here's the sweet spot. Total cost of building ownership hits the crossover mark at 21 years, whereas simple payback would be a 30-year mark. This is a summary of the total cost of building ownership analysis. The gold line shows the dollar figures that are associated over that 60-year period. Here we have average monthly cost of ownership on line 4, and then the total cost of building ownership per year per meter squared. So significant differences. And in Nova Scotia, the building case is favored because we have $100 or $100,000 contribution potential from Efficiency Nova Scotia. We have really high energy costs. We also have a PV rebate that wasn't factored into this current analysis. And we have PACE programs that we could potentially dive into. Total cost of building ownership is going to improve as we get practice, looking at this kind of an improvement in what EnergieSprong did over 5 years, cut the price tag in half for those deep energy retrofits, and then also cut the site time to less than 7 days. We can improve that with volume because our estimated consulting costs would go down. And of course, improvement with insurance restrictions. It also improves with the market. Here in Nova Scotia, we have oil as one of our, I think about 50% of all the MURBs in Nova Scotia are heated with oil. So will it be available? Will it be affordable? What about the carbon tax? We can help clean up the grid. And then big time in the next few years, all of these older buildings are going to have to compete with new high performance buildings. How are they going to do it? That's the big question. They're going to do it because they are just as good as in terms of energy. There you go. 5 minutes over, but here we are. What are your questions?
Awesome. Thanks, Shawna. Yeah, okay, so before we open the floor to questions, I do want to let everybody know that these sessions are recorded and they'll be posted on our website, so you'll be able to go back and listen to Shawna's presentation probably later next week. And then just a quick reminder, there's lots of questions, so I want to get through this piece, but we do have the same rule as always. Please no sales pitches in your questions, or that includes statements disguised as questions. But I've been looking through and it looks like we've got a lot of great questions. So thank you, Shawna, for an amazing presentation and diving us into that case study. I learned a lot. So we've got a few questions in the box here. So the first one's from Robert. It says, I love the rhetoric of being ambitious, so needed, and getting the whole DER done at once. Renos and retrofits are already a tough thing to financially handle for many, and I imagine doing all the retrofits at once will just exacerbate this dynamic. Do we have the right financing options in place now to be able to enable homeowners to pursue a whole DER at once?
No. Next question. No. There are some programs that I think could be expanded to do that work, but we really don't have anything that would look at a single financing package that would typically take somebody from where they might be to a net zero or deep energy retrofit, because those are like, especially for a single family home, if it's on the shoulders of the homeowner to actually do that piece. I think there's different ways we can look at how we, not value, yeah, who's in charge. So I'm going to bring this up. I brought it up in several different presentations, but it's really kind of a cool way to look at things. And it's Bridgewater here in Nova Scotia. They are working on the Smart Cities program. They've got a nice chunk of money to explore a different way of looking at energy use in a community. And what they're looking at, totally top level discussion here, is creating or changing the city into being the energy manager for the municipality in the same way that they are the manager of sewerage and water. That would mean that they could take it off, the improvements would be taken off the shoulders of the individual homeowners and could be done in a very well-managed way by a workforce that is trained and will meet the standards required by the municipality. So that's one option. There's also public-private PPSCO, public-private energy service companies. Vermont Investment Corporation has pioneered that piece. And I'm working with a couple of other folks, Bruce McCullough, who I saw in here, hi Bruce, on bringing that into Nova Scotia as well. And what does that look like? So it's hard to say what could happen in terms of everybody getting deep energy retrofits all at the same time, but certainly looking at laddering them or phasing pieces. I think the bigger thing is we need to have a plan. So instead of going, oh, well, you could get this incentive, to get your windows improved, or you could do a little bit of attic insulation or this or that, it's actually that we have to see a bigger, broader, more umbrella-like plan for the building. What's going to happen to this building over the next 1 year, 5 years, 10 years, and how does that impact how we can reduce the energy? I think I almost answered that.
Great, thank you. The next question I've got here is from Liam Cook. It says, how can government staff sell the capital cost to defer operational costs when the capital and the operating budgets are effectively siloed from one another? Similarly, are the non-energy benefits, like for example, insurance savings or property value, enough to sell this to landlords when there's a split incentive of tenants paying energy costs?
So we did 2 case studies on this paper study for Ecology Action Center. And the other case study that I didn't include here, we did the similar analysis on it. And that organization that has a larger portfolio is actually looking at doing the work. So I think that there's another layer in there. If the property owner has a small portfolio, or maybe the property owner is an individual who is closing in on retirement, for example, they're not going to see the value, but a larger organization with a larger portfolio who could potentially see this as a way to fold in the utility costs so that they could actually see better tenure in their existing occupants, would mean that they would have fewer turnover cycles for their tenants. So there are a lot of variables in there, and Liam, that's kind of like, that's kind of where my head starts to go, I don't know how we do this, because my focus is really, my expertise is in the building part of it, and then I'm really sort of not an economist. So it is a big question, and it's always been a big question, and I certainly don't have all the answers.
Thanks, Shawna. Another question here is, can you speak to the strategies to minimize embodied carbon with prefab panelized retrofits?
From the actual materials, when we look at wood frame plus fibrous insulation such as cellulose, then we're using low carbon materials on the outside of a building. I tend to look at this in a more regional focus in terms of other types of materials where I would not recommend higher embodied carbon materials for a new build, because we have a lot of different options there. I would definitely look at in Nova Scotia, where we have really high greenhouse gas emissions from our electricity, and other people who are not using electricity for heat are currently using oil for the most part. We have very high embodied carbon in our buildings, and then just being in the generation of energy. So from my point of view, I would see that anything that we could do to improve energy or reduce energy consumption in any building we need to weigh that against what kinds of materials we're using. Certainly here in Nova Scotia, if we're looking at moving people off oil and onto electricity, we are going to put more load on the grid, which is why we've gone to a net zero project, because that's actually, in some senses, counterbalancing those issues. And I lost my train of thought where I was going to go with that. So next question.
Okay, thank you. Next question is in-house. Brendan Haley is asking, do you think panels and cost reductions are possible in single-family dwelling homes?
Yes, absolutely. Absolutely. I think that we can really, there are ways to do this that, like in Canada, that are very powerful. We have some major urban centers that could use, that could build into factory building or production lines like that. But in here, like for example, in rural Nova Scotia, where we have a very dispersed workforce, and we also have a lot of people who are seasonally employed, then we could actually look at creating small shops, doing workforce development. The nice thing about this kind of work is that you can't outsource it. It has to be done here. I'm sure there's ways that it could be funneled off outside of a local area, but to keep everything local means that you're doing workforce development. And so those are pieces, I think, once you get it up and running, then you get, like in the EnergieSprong example, they dropped their costs by half and they improved their system so that they can be in and out of one building within 7 days. So that doesn't mean the process was shrunk to 7 days. It means that their impact on the building was within 7 days. So I think there's definitely huge opportunity for us to improve, to get this started and then improve our efficiencies on it.
Great. And in alignment with workforce development, I've got a question here that says, besides financial barriers for DERs, workforce development and training and availability seem to be the main limiting factor. Do you recommend, what do you recommend Canada and others do to address this problem?
Well, what I really like about this particular approach is that it's not creating a different skill set. It's creating opportunities for those who are underskilled or underemployed to create some skills that would work within their community. And what I really love about this whole process is that you're not going to hit every house in the first year. You're certainly not going to go up to a house that's got 5-year-old siding and say, hey, you need to do this now, because nobody's going to pay that. What we need to do is cycle it over many, many years. As many, well, it's going to be many years, but it's so frustrating to say, yeah, we need to do this over many years when we have this crunch of like, how do we manage our greenhouse gas emissions? So local small shops doing this work over many years, you have the cycle. So when maybe we've got over a period of 10 years, we've got a certain number of houses that we can do the work on. By the time those houses are done, there's going to be houses that now have cladding that needs to be replaced. And I'm talking about replaceable cladding, but there's also, issues with brick, et cetera, spalling and needing repair. So workforce development and changing how we perceive this, I think that one of the ways that this kind of work could fly really well is using social enterprise models. So I'm going to jump back to this thing I mentioned earlier, which is a PPSCA, which is a public-private energy service company. Many words, short thing. And essentially, it's stripping out the need to be profitable from the ESCO model, right? You want to make sure that it floats and is sustainable, but it doesn't have to make money for investors. So a social enterprise model might be a really great way to shift this kind of a process so that we can actually work on training youth in trades, taking advantage of small localized shops that can basically act as formal or informal apprenticeship programs for people to learn this kind of a process.
Thank
think
you
I'm
for
answered that.
thank you for that answer. Yep. Next question. How are you doing? I'm kind of giving you a question marathon here.
I'm okay.
Great.
I still got half a glass of water. I'm good.
Fabulous. There's many questions in the box here. So if you feel comfortable dropping your contact info at the end of the presentation for folks who didn't get to their question, that'd be great. Next question is, any tips on communicating this complexity and the benefit of thinking lifetime over cost in their decision making? So the comment around, it's one thing to convince us as pros and attentive pros, but how do we communicate this to others? Any tips on that?
Yeah, I think that if we started with looking at total cost of building ownership and pointed that analysis at MURBs, that we would see business decisions being made around that. I think for single homeowners, it's a lot different. It's a lot more challenging, right? Because there's a lot of misconceptions around how long people stay in houses and what they want to do to houses and how much they're willing to spend. So for example, when we talk about retrofits, a lot of times people say, oh, well, energy efficiency, I need to see a 5-year payback on that. It's like, why? Because that's what we've been told, that on average, people sell their houses every 5 years. Well, that's a little bit of a misrepresentation of how home ownership goes in Canada. In fact, the average tenure, so the average amount of time that somebody will own a house in their life, is 13 years, which is a lot different than 5 years, right? Houses might sell on average that way, but you've got a raft of houses that are selling when people are flipping or moving through markets, right? So as markets change and impact, I have several friends who have purchased several different houses over the last few years, and they build some equity in one house and then they move on to another and another. That skews how the stats that were available to us to a shorter period of time versus instead of actually looking at how long do people stay in their houses. On average, it's 13 years. So that changes how we change that metric, then we can also change, what do you think about staying in this house for 13 years and how could you fix it? How could you improve it? And how can we help you improve it as engaged professionals? If there's a way to shift the financial burden off the shoulders of the individual, for example, PACE programs or local improvement charges, then that's another step forward. But those programs are also limited in terms of how much money a municipality can afford to put into those programs. So there's limitations and there's a bunch of challenges around those things too. But I think that starting with MURBs is a really good option. And then, and then stepping out a little bit more than that, starting with social housing or affordable housing is also even a better place to start, because then we're working with those who need energy security more than a lot of other people in society. So
thanks so much, Shawna. I'm going to stop us there. We do have a whopping 14 other questions in the box. What I'm going to do really quickly is show you exactly how you can keep the party going. If you sign up on to the DiscoverEE Hub, you'll be able to jump into Discovery Sessions. It'll take you into this channel, click the light bulb, ask your questions here, share any reflections, and let's keep this conversation going. It's an important one. So I wanted to show you how to do that because there's many of you that had some great questions, and I'll poke Shawna to take a peek at this later on. So thank you for that. And yeah, Shawna, thank you so much for your time and your expertise.
You're welcome.
Super appreciate it. And thank you to everybody else for joining us today for another great conversation. And we look forward to seeing you all next week for our next discovery session. So stay safe, stay cozy, and enjoy your weekends. Take care, everyone.
You forgot something.
Oh, I did forget a very exciting announcement. another great exciting thing that's going on between the DiscoverEE Hub and Blue House Energy is that we're launching a training giveaway. So starting today for the rest of the month, you'll be seeing posts being circulated all over online on all our platforms. And it's an opportunity for folks to join the hub, join the conversation, refer a friend, but also be eligible to win $100 off training. And so any way that we can help people get into this sector is what we're really trying to do. And so you'll be seeing some opportunities like that starting to circulate online. So be sure to share the word and let's get people in EE jobs.
Yeah, and we'll be diving into the hub ourselves as well. So we'll be there.
Lovely. Okay, thank you everyone. Have a great day.
Ciao.